Hello guys, welcome back to the tutorial on the design of machine element. We'll continue the problems on the keys and today we'll see some more problems on the design of keys. Okay, so I'll read out the problem first. A 19 kilowatt, that is a power, and 1450 rpm, that is speed, has a steel shaft. The extension of the shaft is 75 mm. Diameter of the shaft is 45 mm. The motor pull-out torque is 3.5 times the average full load torque. Okay, that is T max is 3.5 times the T mean. Assuming the yield shear strength of 54 megapascal and crushing stress of 180 megapascal for a key material, designers Sankey adopt a factor of safety as 2.5. Okay, so first thing what you have to do is you have to write the given data properly, read the sentence by sentence and try to write down the given data. Okay, so given data will be P is given as 19 kilowatt, N is given as 1440 rpm. Okay, D is given as 45 mm, T max is given as 3.5 times T average or T mean, sigma y is given as yield stress, that is how much, 54 megapascal, and sigma c, that is crushing stress, is given as 180 megapascal and factor of safety is given as 2.5. Okay, let us start the problem. Now we'll take the extension of the shaft is equals to the length of the key, that is the 75 mm, which is already mentioned in the problem. Okay, now whatever stress they have mentioned here, they are the maximum stresses and we have to use always the allowable stresses. So divide the given stresses by the factor of safety in order to get the allowable stresses. So 54 by 2.5, how much? That is 21.6. That will be our allowable shear stress. Fine. Next, we'll calculate T average equal to P into 60 divided by 2 pi n. Now substitute power. P is 19 kilowatt, that is 19 into 1000 into 60 divided by 2 pi into n. N is what? RPM speed, that is given 1440. So once you evaluate this, you will get the value as 126 into 10 raised to 3 Newton mm. That is the T average, but we have to calculate T maximum. So T maximum may be equal to, yes, now D equal to 45 mm, that is given in the problem, correct? And now for D equal to 45 mm, we will be having the width equal to 14 mm, thickness equal to 9 mm, and length of the key equal to 75 mm, which is already mentioned in the problem anyway. Next, we have to check the stresses for the keys. We have to check here whether the design for the key is safe or no. Okay. Now tau equal to 2t divided by LW into D. T is the maximum torque, L is the length of the key, W is the width of the key, and D is the diameter of the key. So tau equal to, substitute all the values which are already given and calculate value of tau, and whatever value of tau you will get, it has to be a less than that of the given in the problem. We are having 21.6 and what is we obtained is 18.61, which is obviously less than the 21.6. That's why your design is safe. Now we'll check for the crushing stress. Now sigma c equal to 4t divided by T into L into D. Again substitute all the values because 4 is anyway constant, T is the torque, and T is the thickness, L is the length, and D is the diameter of the shaft. So crushing stress what we will get is 58.07, which is less than the 180. That's why your design is safe. Since the induced stresses are less than that of the maximum stresses, whatever you are designed, whatever you are assuming the problem, those are correct. Therefore, design of the key is safe. And yes, dimension of the key length is, therefore the dimension of the key are 14 into 9 into 75, where 75 is the length of the key. Fine. And 9 is the thickness and W is the width of the key. We'll solve another one problem. A shaft of 30 mm diameter is transmitting the power at the maximum shear stress of 80 megapascal. Okay. If a pulley is connected to the shaft by means of a key, find the dimensions of the key so that the stress in the key is not to exceed 50 megapascal and length of the key is 4 times that of the width. Fine. So these all parameters which are given in the problem, you have to write down in the heading that is given data. So write down T is given, tau is given, okay, L is given, length is 4 times that of the width. Start with the torsional shear strength, T equal to pi by 16 tau 1 into D cube. Substitute all the values and calculate the value of T. Okay, so T is 424115 Newton mm. Now you consider the shearing strength of the key. We know that the shearing strength of the key formula which we already solved in the previous slide, that is T equal to LW into tau into D by 2. Substitute all the answer. See, width of the key we don't know. Okay, so keep as it is and find in terms of W square. So because 4W into W is 4W square, so 4 will shift to that side, so will remain with the W square equal to 141.37, or when you take a square root of that, you will find W equal to 11.90 mm. Therefore length of the key is equal to 4W, or L equal to 4 into 11.9, which is equals to 47.6 mm. Okay, thank you.